Hey guys, my name is Kay Johnson. I'm going to be talking to you about magnesium alloy. So magnesium alloys are essentially a lightweight material made by combining magnesium with other elements such as aluminum, zinc, or manganese. And these addition of these elements enhance magnesium's natural properties, making it stronger, corrosion resistance, and easier just to work with and all. So some key physical, chemical, and mechanical properties of magnesium. We'll talk about probably one of their most important properties. A lot of industries use this for the magnesium for this. Its lightweight application. They're known for their low density, ranging from 1.7 to 2.0 grams per centimeter squared or cubed. This lightweight characteristic makes them a preferred choice when you're using applications such as aviation or cars or portable electronics in this case. Another key physical property is their high thermal conductivity. Magnesium excels at dissipating heat, which is crucial for applications where heat needs to be efficiently dissipated, like in motors or in cars and engines or other electronic devices. So let's talk about some of the chemical makeup, the chemical properties. Magnesium alloys are chemically reactive and prone to corrosion, especially in environments like with humidity or exposure to salt water. This makes them pretty vulnerable to degradation unless treated with alloy or elements like aluminum or zinc. So to control that corrosion, in addition of aluminum and zinc and other elements, it improves that resistance, making it a suitable application for any long-term weather or harsh environments. Some mechanical properties here are going to be that they typically have a tensile strength between 180 and 130, which is lower than some other metals like steel, but they still offer great performance. For applications that don't require like a high strength to weight ratio. They also have good fatigue resistance, making them suitable for parts that undergo repeated stress. Fatigue resistance, for example, would be when in aviation, when aircraft descend and ascend in altitude, the cabins actually fluctuate. The metals up there bend, expand, and retract. So you got to imagine if you're going back and forth many miles, many trips a day, that cabin in that plane is going to be expanding and retracting multiple times a day. So it's going to have to be able to take those stresses of those different, points. So other important properties of magnesium they're gonna be highly formable. I mean, they can be cast, they can be forged, extruded, all pretty easily. Just temperature and temperature management is pretty essential during the manufacturing of this material to avoid any cracking or anything like that. Its recyclability. That's some important properties to end use here. Its recyclability. I'm sorry, they're more sustainable than some choices of other materials because of the recyclability, and better for other electronic applications, so they can be broke down and reused. Yeah. So now that we've covered the properties of magnesium alloys, let's look at how they're processed to get from raw materials to final products, including how they're mined, refined, and fabricated. Okay, so material processing on magnesium. There are two main processes when it comes to mining and refining magnesium. But magnesium is mainly derived from minerals like dolomite and magnesite, which there are two primary methods of refining magnesium. So one is going to be the pigeoning process, or the pigeon process. Essentially, magnesium oxide is reduced with silicone at really high heat to obtain a pure magnesium metal. This is one of the most commonly used methods to obtain this metal. There's also electrolytic reduction. I'm pretty sure this is only used in specialized applications, but in this process, magnesium chloride is electrolyzed to produce magnesium metal. So fabrication techniques are going to be the most common ones are going to be casting, forging, extrusion, and machining, of course. So let's talk about some casting. Magnesium alloys can be cast into many different molds to create complex shapes. A process that's widely used in automotive and aerospace industries. Um, parts like camshafts, gears, transmissions, all these things you're going to have some pretty complex molds that are going to be need to be made. And this material is pretty good for that. So forging is used to create stronger parts by shaping magnesium alloys under high pressure and temperature. So essentially taking the magnesium alloy and heating it up, and like the Tony Stark scene, boom, 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 hammering it down, softening it up. Extrusion involves forcing magnesium through like a die, so to create a long shape, essentially, um, with a constant cross section. This is ideal for any application like structural components or things in airplanes. Because of magnesium's soft nature, machining is pretty easy. It's relatively easy, um, making them really suitable for precision parts and electronics. So any type of parts that you want to put on motherboards, stuff like that, it needs to be machined down to millimeters, centimeters. This is a pretty good material to be using it on. So there's some challenges to consider when processing this material. Um, Despite a lot of advantages magnesium has, the production and processing of magnesium it requires super careful temperature control and monitoring, and any excessive heat or improper strain management can cause cracking during the process or poor mechanical properties when applied to its real-world application. So with an understanding of how these are produced, let's move on to methods and quality testing for the standards after these things are produced and sent out. Thank you guys. So some important properties of magnesium alloy, like I said earlier, are going to be its formability and workability. It's easily cast, forged, and extruded. They require careful temperature strain and management, especially not to crack or ruin the quality of the piece. Used in most electronic applications for their lightweight and thermal conductivity. Um, Found in electronic devices that everybody uses around the world now, your phone, your laptop, your TV, your iPad. Um, so the production and recycling process is pretty energy intensive, and yeah. So let's talk about some quality testing procedures and standards for magnesium alloy. After we've gone through the industrial part of it, we've made the part. Now we've got to mold this part and fit the standards, the quality standards that we're supposed to fit in order to mass ship this product. So magnesium tests include tensile and fatigue tests to see its strength and resistance to deformation under many different weights. NDTs, like non-destructive testing, is crucial for ensuring the structural integrity of magnesium without causing any damage on the outside. So essentially an NDT could be like ultrasonic testing, which is an X-ray to detect internal defects and check on the structural integrity without really damaging the material or impeding the material in any way. The tensile testing is a test to essentially measure how much stress an alloy can take before it breaks. And magnesium alloys are tested for tensile strength to make sure that they can handle the stresses that they will encounter in their end-use applications, meaning that tensile test is going to be equivalent or equivocated, however you want to say that, to where that application or where it's going to be applied. Um, so some fatigue test measures how well the material will resist to repeated stresses over time. So this is especially important in automotive and aerospace industries where your parts, like I said earlier in the cabin example, they're subjected to constant changing forces. So yeah, some quality standards, the ASTM B10 or B107, specifically for die-cast magnesium alloys. I don't know if I didn't put this one up. You can't see it because of my camera there, but it's, I believe, ISO 9001. It's an international standard for quality management systems, just basically ensuring that manufacturers consistently produce quality products. So now that we've covered the testing and quality standards, let's go ahead and phase over and explore the wide range of industrial applications we can use with this product here and where it truly shines. Alright guys, let's talk about some industrial applications for magnesium alloy. So, magnesium alloys have great benefits for any operation you're wanting to run. Their lightweight, strength to weight ratio, their conductivity, and their machinability. It makes them perfect for many applications. For aerospace industry, magnesium alloys are extensively used for parts that need to be both strong and lightweight. Aircraft manufacturers use magnesium alloys in components like the engines, the fuselage, and even seats to reduce the overall weight of the aircraft. Boeing likes to reduce the weights of their aircraft because it's fuel efficient and it's, well, just that. You use less thrust when your plane weighs less. But when you're using magnesium alloys to build, say, plane wings or anything like that, or flaps, when you see these wings built in industry, the way they're tested before application is one of the most bizarre things you'll ever see. These wings are bent almost 90. So if you see the fuselage, say this is the fuselage of the plane, these are the wings, both horizontal on each side. Now in application, those wings only go up about like this when in flight. They never really go past that. But in the industry, when they're tested, they're bent almost all the way up like a flower shape. The wings are bent all the way up and cocoon around the fuselage of the plane. And they're never gonna meet 90-degree an angle, but that is just the industry standard. That's how they have to be tested. But that will show you just how strong these metals are, and having a lightweight metal in a strong lightweight metal, you have lighter wings, a longer cross section, massive surface area. It'll just help create lift a whole lot more, and that's just a massive application for an alloy like that. In the automotive industry, especially in the automotive sector, yeah, magnesium alloys are used in almost in all various parts, including the engine blocks, the transmission housings, camshafts, nuts and bolts, and the wheels, by replacing heavier materials with these lighter magnesium options. Automakers can reduce the overall weight of the car, make it more fuel efficient, leading to better cost and lower emissions. So in the electronics industry, magnesium alloys are found in everything: your smartphone, your camera, your laptop. They're in the casings of all that. They provide great durability in electronics, and they also offer a lightweight application. So, in other industries, like besides aerospace, automotive, and electronics, magnesium alloys are used in military, medical, consumer products, from military vehicles to medical implants. I'm not sure if they're used on needles, but they can be those very tiny. Their machinability allows them to be machined into very small parts. So ongoing research into these compositions, into the manufacturing techniques of magnesium and these alloys, they continue to prove, and the performance and sustainability of magnesium alloys continue to prove over the years, ensuring that they will continue to expand in the industry. So, yeah, in conclusion, guys, magnesium alloys are a very versatile material. They offer a unique combination because of its strength, its lightweight application, its thermal conductivity, its machinability. It's ideal for many, many, many applications. And they play a critical role in all of our industries around the world today. So, guys, I appreciate you giving me your time to listen to this, and thank you, man. Have a good one.